All right, problem number 2. Which figure shown, use the figure shown, to answer the following question. Turn it in. Goes in the basket. Which figure in the diagram is a rotation of figure 2? So this is something that I could use tracing paper for, which you guys have access to on Friday when you come in to take the test. This container of tracing paper will be up here. You are welcome to come and help yourself to as much of it as you would like. So if I trace around figure number 2, making sure to get that leaf, and then I can take that figure and I can rotate it. If I rotate it around, it looks like this, which matches figure 5 and figure 4. So figures 5 and 4. Are rotations of figure 2. Which figures in the diagram, which figure or figures in the diagram are a translation of figure 5? Figure 5 again looks like this. A translation is a slide or a shift. If I slide straight down, figure 4. And then which figure is a reflection of figure 3? A mirror image of figure 3? There are 2 answers here.
Figures 2 and 4.
Figures 2 and 4. 3 reflects like this to give us figure 4. 3 can reflect like this to give us figure 2. So figures 2 and 4. All right, what else from the review would you guys like to see? Yes. Number 3? Absolutely. Find the coordinates of the point E, -5, 24, for each transformation described. If we are going over the line y equals x, what is that rule? Yes, we're going to switch x and y. So my point E prime would be 24, -5. For the test on Friday, you have to know your rules. If you don't know the 6 rules that we've used, I would highly recommend making flashcards. If you need some 3x5 cards so that you can make flashcards for the rules, I have those and I'm happy to give those to you at the end of class if you would like some. But you have to know the rules here. Reflecting over the x-axis, what's our rule there? Yes, x stays the same and y changes signs. So my point E prime, x stays the same, so -5. Y changes signs, so -24. So -5, -24 would be E prime. Rotating clockwise 270 degrees about the origin. So for this, we're going to switch x and y, and then we will match signs to the quadrant. So I need to figure out what quadrant we're going to be going into. If I just do the switching, that would be 24, -5. But I don't know that those signs are correct. But I know the order of the numbers is correct there. All right, my point E, -5, 24, is going to be over here in quadrant 2. -x, +y would mean quadrant 2. We're going to go 270 degrees in a clockwise direction. That would put us here in quadrant 3. Are the x's positive or negative in quadrant 3? Negative. What about the y's? Also negative. So my x and my y over here need to be negative. So negative 24, negative 5. If I rotate counterclockwise 270 degrees about the origin, again, 270 degrees means I'm going to switch x and y, and I'm going to match my signs to the quadrant. So again, I know the order here is going to switch. So 24 and negative 5, but again, I don't know if my signs are correct or not. I need to come over here and sketch a little quick graph. Again, E is in quadrant 2, negative x, positive y. 270 degrees counterclockwise is going to rotate me into the first quadrant. Are the x's positive or negative in that first quadrant? Positive. Are the y's positive or negative? Positive. So I need a positive x and a positive y. So 24, 5 would be my E prime. Rotated counterclockwise 90 degrees about the origin. So just like with 270 degrees, we're going to switch x and y. There's only one rotation where we don't switch x and y. 180 degree rotation, we do not switch the x and y, but for every other rotation about the origin, 270 or 90, we're going to switch x and y around. All right, my point E is up there in the second quadrant. We're going to go counterclockwise, so same direction as in the question before, but we're only going to go 90 degrees counterclockwise. That's going to put me in the third quadrant. You guys already told me that that's a negative x and a negative y. I have to switch my x and my y and make sure they're both negative. So I get negative 24, negative 5. Notice that these two end up in the exact same position, so my E prime has the exact same value. Rotating 180 degrees about the origin. No switch on this. No switch. All we do is change the signs. So E prime, instead of being negative 5, it's going to be positive 5. And then instead of positive 24, it will be negative 24. Right. And then that just leaves us with this last one here, part G. It says to map point E to point E prime. And then it has this notation here. What is that trying to tell me to do? Yes, we're going to translate. So to the x, we're going to add 11, and to the y, we're going to subtract 9. You're absolutely right. We're going to translate. So my point E is negative 5, 24. To the negative 5, we're going to add 11, and to the y, we're going to subtract 9. That will give me E prime. X is 6. And y, when I do 24 minus 9, I get 15. So E prime is 6, 15. right. What else would you guys like to see from the review? Yes. Number 9, absolutely. Number 9 is about our symmetry. The first shape we have here is a heart. We want to know whether or not it has line symmetry. Is there anywhere that I could draw a line and fold it across that line so that the halves would match up perfectly with each other? Yes, if I draw vertically, let me make this a dashed line. If I draw vertically right through the center of that heart and I fold it across that line, they match up. Are there any other lines of symmetry? Any other places where I could draw a line like that and fold it across that line, fold it in half, and they would match up? No. So this has one line of symmetry. Do we have rotational symmetry? Can I rotate this shape around? Not really. If I trace over this shape on my tracing paper and I rotate it, I have to be able to stop somewhere before I get all the way back around to the beginning in order for me to say that I have rotational symmetry. If I have to go all the way back to where I started, then we say the figure does not have rotational symmetry. So this one does not have rotational symmetry at all. I had to go 360 degrees all the way around until it matched up with itself. All right, and then on part B, I've got a clover leaf, 4-leaf clover, in fact. Does this have any line symmetry? Yes, where could I draw the lines of symmetry at? I can draw vertically. I can draw horizontally, so there's at least 2 lines of symmetry there. Can I draw in any other lines of symmetry? Diagonally. On both sides. If I were to fold it over this diagonal, the leaves are going to land on top of each other. And if I do the other diagonal, same thing. So yes, we have line symmetry. We have 4 lines of symmetry. What about rotational symmetry? Do you think we have rotational symmetry at all? Yes. Let's find out what our rotational symmetry is. So I'm going to come up here and I'm going to trace around my shape, understanding that I only do so good of a job, so I have to leave some room for human error here as I'm looking at my rotations. All right, and this is the top. I need to know that so that I know when I get back to the beginning. And then I'm going to rotate this around until I get back to where I started. When I get right about here, it matches up perfectly. So there's one stop that I could make, but I'm not all the way back around to the beginning yet. So there's one. And then I keep going. When I get it down here, it's perfectly upside down. That's another place that I could stop, that it matches up with itself. So there's 2. And then I can keep going around. Matches up with itself here, so that's 3. And then I continue rotating around. That gets me back to where I started. That would be a 4th stop. So yes, we have order 4, or we would say 4-fold. And now how do I find the magnitude? I would divide what by 360?
4.
No, I do not divide 4 by 360.
360 by 4.
I divide 360 by 4. You get a very different answer when you do it the other way around. We have 360 in our numerator, and we have the order of 4 in the denominator. And so that gives us a magnitude of what? 90 degrees. What else would you guys like to see? What other problems would you like for me to go over? Yes, sir. Number 10? Absolutely. Let's go look at number 10. Ooh, this is a really good one. We had one like this on the skills check. This one is kind of going backwards from what we did with translations, or what we practiced the most with translations. In this one, the figure has already been translated, and I need to find the vector. I need to find the numbers that describe this movement. Which figure does not have the primes on it? The one on the left or the one on the right?
The one on the right.
The one on the right. So the one on the right is my original figure. We call that the pre-image. And so the one on the left would be the image. And we need to figure out exactly how far each of those points moved. I can pick one point on each of these, and as long as it has the same letter, I can count between those. Because my point M moved and became M prime. My point N moved and became N prime. My point L moved and became L prime. And all of these points moved the same direction and the same distance. I just need to figure out how far that is. So let's go from M to M prime. First of all, if I start here at M, do I move left or right? I move left. How far left would I need to move from M to get right above where M prime is? 5. So we go 5 to the left. The first number in the vector is always going to be the left-right number. So you have to count left or right first. Since I went 5 to the left, would this be a positive or a negative 5? Negative 5. The second number in my vector is my up-down number. Do I move up or down from where I'm at the end of this arrowhead to get to M prime? Down. How far down? 2. So should I have a positive or a negative 2 for the second number? Negative 2. So negative 5, negative 2 is the vector that maps triangle LMN onto triangle L prime, M prime, N prime. And I can check that with these other points too, because remember, it doesn't have to be point M. You can use any pair as long as they have the same letter. So when I look at, like, say, L to L prime, 1, 2, 3, 4, that goes left 5. And then 1, 2, down. I could do the same thing with point N. But what I'm trying to say here is it doesn't matter which pair of points you pick out. Again, they have to have the same letter, so I can't do M and L prime. It has to be M and M prime, N and N prime, or L and L prime. They have to match each other. What else would you guys like to see? Number 12? Absolutely. What are the coordinates of the image of triangle STU with vertices S, -3, -2, T, -2, 3, and U, 2, 2? This is another one of those rules that you need to know. I would make a flashcard for these if you don't know these rules. How do we reflect over the line y equals -x? Yes, we're going to switch x and y. And we're going to change both signs. So I come over here to S, I flip the order around, and I change both their signs. So I would have a +2, +3 for S prime. With T, we're going to switch the order. We're going to change the 2 to a positive, but the 3 to a negative, so -3, +2. And to get u prime, we switch these two around, but 2 and 2 switched is just 2 and 2. But then I have to change both of their signs and make those negative. So u prime would be -2, -2. What else would you guys like to see? Number 8? Yes, absolutely. Let's go look at number 8. Number 8 says graph the following segment, period. So let's stop and do that first. So I have my ordered pairs here. 3, 2. Remember, when you're looking at ordered pairs, the first number is always telling you left, right. Tells you how far left or right to go from the origin, and the second number tells you the up, down. So 3, 2 would be right here. That's our point G. And H is 4, -5. So 4 and -5 would be right here. There's my point H. And you guys will have straight edges to use tomorrow, or not tomorrow, Friday on the test. That'll be one of the things that you need to pick up when you come in the room. You'll grab a calculator and a straight edge, and then any tracing paper if you would like it. Okay, so that's the first thing that I do. Second sentence, it says, then graph its image after a rotation of 180 degrees. What was my rule for a rotation of 180 degrees? Change signs. No switch. Change both signs. Morning. Thank you. So for G prime, I'm going to change both of those signs. So it becomes -3, -2. And H prime would be -4, +5. So we graph -3, -2. That would be right here. There's my G prime. And -4, +5 would be up here. There's my H prime. Please don't forget to connect the points to make the line segment. If you're not labeling the points or you're not connecting the dots, you are losing points. Like you are losing credit on these questions. You have to do that piece. All right, and then it says followed by a reflection over the line, x equals -6. So we have to find -6 on the x-axis. -6 on the x-axis is right here. And then we go through the x-axis at -6. So that means I have to go which way, vertically or horizontally? Do I go vertically? Vertically. I have to go vertically to go through that point and through the x-axis. If I go horizontally, it just traces right on top of the x-axis. And they didn't tell me to go over the x-axis. All right, now from here, we need to figure out how far this purple line segment is from that line. So H prime is 1, 2 away. So I go 1, 2 on the other side to get my mirror image. There's my H prime. And then we do the same thing with G. How far away is G prime from that line? 3. 1, 2, 3. So on the other side, I go 1, 2, 3. And then I put down my point for G prime. And then I need to use my straight edge and connect those two together. I don't want to forget to actually write down what those ordered pairs were, though. And I have to make sure to get them in the right spot. This is one of the things that I saw on the skills check the other day. People were taking the point that was on top of the line segment and putting it on the top line. Well, that only works if the letters match. This point up on top is H. We have H, sorry, that shouldn't be a single prime. That should be H double prime and G double prime. I just realized that I hadn't given it the double prime. Why does it get the double prime on that?
Because it's a reflection of the prime.
Yes, we took the prime and then we did something else to it. Yes. Do you have to put the vertical line there? No, but you have to know where it is so that you can do the reflection. Yes, you do. You have to put the primes in the double primes or it is incorrect. Yes. All right. We need G double prime, which is down here. What is that ordered pair? -9, -2. Yes. And then H double prime is up here. Where is that point at? -8, 5. Yes. -8, 5. Remember, the first number you put down in an ordered pair is always the number that you read off of the x-axis. The second number is what you read off the y-axis. Please, please, please make sure when you are graphing yours that you are putting the line segments in, you are connecting those dots, and that you are labeling the points. There is a difference between H prime and H double prime. So you want to make sure that your first transformation gets the primes. The second transformation gets the double primes. Yes. Yes. What else would you guys like to see?
11.
Number 11, yes. That'll finish off the back page. Number 11, we have been asked to identify what type of transformation. These are all called rigid motions because my shape stays rigid. It either gets flipped over, it gets rotated around, or it gets slid, but it doesn't get any smaller, it doesn't get any bigger. It stays the exact same shape, the exact same size. All right, let's see if we can figure out what's going on. Let's look at the middle one first. That's an interesting thing. A translation is a slide, so it starts off with this one, WXYZ. If I take WXYZ and I slide it up and to the left, it lands right on top of that one. So this one here is a translation. This first one, does that look like a mirror image or does that look like a rotation? Mirror image. A mirror image would be a reflection. And you can check all of these with the tracing paper tomorrow if you want to on a problem like this. If I'm checking for a translation, I would trace around the original shape, the one that doesn't have the primes, and I would slide my figure. If it matches up perfectly with a slide, then it's a translation. For a reflection, I would trace over the shape that does not have the primes, my original shape, and then I would turn my tracing paper over and try to match it up with the other shape that's on there. If it matches up when I flip the tracing paper over, then it would be a reflection. Which means this last one is most likely what? A rotation. Let's check and see. I'm going to trace over this, and I'm going to see if I can rotate it. Now I need to keep track of where these points are. A is here, B is here, C is here. I'm going to rotate this and see if I can make A prime, B prime, and C prime match up. It looks like if I take it just a little bit further, A prime, B prime, and C prime are matching up with A, B, and C. So this one is indeed a rotation. All right. Now page 4 in your packet is done. What else would you guys like to see? We still have about 10 minutes until the bell for the announcements rings. Probably enough time for 3, maybe even 4 more problems. Which one? Number 6, absolutely. Number 6 says, using triangle FGH, graph and label its image after the reflection over y equals -2. So I need to draw in y equals -2 first. So I need to go to the y-axis. I'm going to find -2 on the y-axis. And then we're going to go through the y-axis at -2. So y-axis -2. Here's -2 on the y-axis. And I want to go through that point with what kind of a line? What'll take me through the y-axis? A horizontal line. Like this right here. And now I need to move each of my points. Where is point F right now? -5, 0. And how many hops away from the line is it? 2. So then I go 2 hops on the other side, and I put my point F prime down. And where did that point land at? -5, -4. All right, where is point G right now? -2, 5. And how many hops is it going to take me to get from G to that line? 7. 1, 2, 3, 4, 5, 6, 7. So now on the other side, I go 1, 2, 3, 4, 5, 6, 7. And I put down my point G prime. And where did that land at? -2, -9. And then last but not least, we have point H. Where is point H at currently? Close. 1, 2. The X number comes first and then the Y number. 1, 2. How many hops to get to the line? 1, 2, 3, 4. So then on the other side, 1, 2, 3, 4 to get my mirror image. There's my point H prime, which landed where? 1, -6. And then what else do I have to do if I want full credit on this problem? I got them on there. I got F prime, G prime, H prime. I need to connect those points. I need to draw the lines in between those points so that I get full credit on this problem. Please make sure before you turn your test in on Friday, like go back and look at all the problems with graphs to make sure that you connected all the dots and that they are on there clearly. I don't want anybody to lose points just because you forgot to connect them. All right, what else would you like to see? Number which one? Number 5, absolutely. Graph and label the following figure and its image under the given rotation. So first thing we're going to do is come in and graph these 3 points. So I have point C, which is negative 2, 2. I have point D, which is negative 1, 4. And I have point E, which is negative 6, 3. I need to move my label for C. There we go. Now I'm going to connect these together. There's my original triangle. And then what are we doing to this triangle?
We are rotating it.
Rotating it which way?
Clockwise.
Clockwise, 90 degrees. So we will switch X and Y.
And change the new Y sign.
Yes. We will match the signs to the quadrant that we go into. A 90-degree clockwise rotation is going to send me over here into quadrant 1, which is positive, positive. We had something that happened on the last homework and something that happened on the skills check yesterday that I want to make sure to stop and pause and talk about. All 3 of these points for this triangle are all in quadrant 2. So I know they're all going to move into quadrant 1 together. If the points of my triangle or the points of my line segment are in different quadrants, then I'm going to look at them just 1 point at a time. I'm going to move 1 point into its new quadrant, then I'll move the next point, and then I'll move the 3rd point. So in that case, I would draw a little axis off to the side to see where each point is going to move to. When all 3 points are in the same quadrant, we can kind of move them as a group. So I'm going to switch the X and the Y for C prime, and I'm going to make sure that both of them are positive. So that would be 2, 2 for C prime. Then for D prime, we switch the order of the numbers and make sure they're both positive, so we get positive 4, positive 1. Positive 4, positive 1 would be right here, so there's my D prime. I can go ahead and start connecting those now so that I don't forget to do it later. And then for E, we switch the order of the numbers, and they end up both positive, so positive 3, positive 6. Positive 3, 1, 2, 3, 4, 5, 6. Right up here is my E prime. I'm going to finish connecting my points. And there is my rotated triangle. Sometimes, especially when we're moving line segments and rotating them, it feels like we might have gotten it off a little bit. Tracing paper can come in handy for that too. You can trace over the original figure. Remember, we're going about the origin, so I would put my pencil down on the origin, and then I would twist the paper in a clockwise direction, and you should see this triangle turn and land on top of the other triangle on your page if you've done that correctly. All right. Anything else you guys want to see? All right, that pretty much takes us to the end of our time. It's 7:57 right now. As always, I have already posted the answer key up in Canvas, and I'll be posting videos for every single class today. If you are on the Canvas page for today, Wednesday, 10/23, review for Module 4 test, day 2, and you scroll down to the very bottom of the page, the videos will be in here once they're up. If you go down to the very, 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 very bottom, the test review key is right here. And so you can access all of my answers that way.